Hello and welcome to Planning and Optimization Software for Sewn Products Industry. Today we'll see how IntelliCut handles orders in which the ordered fabric is received with variations in width, shrinkage and shade. So let's go to the software. We are on Role Allocation Solution screen. Till now in this order we have run the cut plan, made few markers and we have ordered the fabric. So now assuming that the fabric is in-house, we'll go to the fabric section and we'll upload the role information. We'll select the Excel sheet containing the role information and we can see that the fabric that we have received, it has come in different widths, different shades and different warp and weft shrinkage. So we'll save this information. And after this, our first step will be to group the fabric and group the lace. So we'll go back to the software and we'll go to fabric grouping, where we'll enable grouping to set the parameters for the grouping of the roles. So by default all the three are selected and we need all these three parameters in our role grouping right now. And in the default these are the grouping offsets. Here it's for the width, it tells us that at a difference of 2 centimeters between the width of two roles, they'll fall under different groups. And in warp and weft shrinkage, at a difference of 1% shrinkage between the two roles, they'll fall under different groups. So these are the grouping parameters that we need to define, and after that we click suggest grouping and the software will automatically group the roles on the basis of the above parameters. So we'll save the grouping, and if we click on this, we'll be able to see the total number of roles in group 1, and these are the parameters in each role. And if we click on group 2, we'll see the number of roles in group 2, and these are the group 2 parameters. After this, we need to select lay grouping. Here we can see the two lays that were planned. The first lay having 182 plies and the second having 44 plies. So we'll click on suggest association and the lays will be divided in different groups. So the first lay that we had of 182 plies, we can see that it did not break into two groups, and all 182 plies will be cut using the roles of group 1. And the second lay that we had, 12 plies will be cut from the roles of group 1 and 32 will be cut from the roles of group 2, so as to use the fabric most efficiently. So we'll save this information. So now the markers are divided, so we need to create the new markers as per the groups. And as we see, this is our next step, that we make the markers and then we allocate the roles to each lay. So we'll go back to the software. We'll go to created marker screen, where we'll enter the marker details. We can see that it tells us that the expected length is 5.929. So we'll enter 5.929 and the expected length for this marker is 5.989. So we'll save and log this information. And after this, we'll go to Run Role Allocation screen, where we'll select all these three lays and we'll click Allocate Roles. And as we do this, the software will run its complex algorithms and it will allocate the roles to each lay such that maximum utilization of fabric takes place. So if we quickly refresh it, we'll be able to see that the roles are now allocated. So now we'll just print the lay slips and we'll give to the cutting floor so that the laying can begin. The lay slip will have all the information, including the group information and the number of plies, total number of pieces that will be cut, the rows they need to pick and the number of plies they need to do from each roll. And then they'll fill the actual scenario. So now assuming that we've given all the three lays to the cutting floor, after this our last step will be to plan the remnants and enter the feedback from the floor, after which we'll be able to see our savings. So we'll go back to the software again and we'll plan the remnant pieces. So now we see that 27 small, 12 large and 19 pieces of extra large are left. Total of 58 pieces. And from both the groups, these are the number of plies that are left. So if we plan on the average consumption achieved by the markers so far, this is how our plies look like. So we'll plan the remnants. We'll plan one small and one large. So we need to enter the details, one small, one large, and then we need to select the group from which we need it to be cut. So we'll select group 1 and we'll click plan and save. So now we see that the end bits have reduced and even the pieces are reduced. We are left with 15 small and 19 extra large. So first we'll plan 19 extra large one way. So we'll plan a one-way marker for extra large. We'll click plan and save. So now we see that only 15 pieces of small are left, and in group 1, 5 way 1 ply is left. So first we'll try to finish this end bit. So we'll plan a one-way marker, one small marker from the same group, and we'll save. So now no end bit is left. We are just left with 10 pieces of small, for which we have fabric left only in group 2. So we'll make a one-way marker for small and we'll select group 2. We'll click on plan and we'll save. So now we can see that all the pieces are cut and all the end bits are consumed. The left fabric that we have is in the form of a complete roll, not in the form of small end bits, but a complete length of fabric. That means we are fine with this plan. We'll click confirm and this will automatically queue all these markers to CAD. And now assuming that the markers are made, we'll go to the created marker screen and we'll enter the marker details for the remnant markers. So we'll quickly enter all the marker lengths. This is 1.98, let's say 80% efficient. Similarly, we need to enter for all the markers with their efficiencies. And we'll save this information. So now all the lays are allocated with the roles, and if we go to the role allocation solution screen, we'll see that all the lays are allocated with the roles, and we can now print the lay slip and give to the cutting floor for the remnant pieces as well. And now assuming that we have received the feedback from the floor, we'll go back to the view lay slip section and we'll enter the feedback. So this lay slips are generally filled with the details. In case there is deviation, we can always change. But now assuming that everything went as planned, we'll just save the left length and the actual plies details. And this we need to do for all the lays. And now we are filling the last lay. And we save it. So now all the feedback from the floor is in the software. If we go to role allocation solution screen now, we'll see that all the lays are completed. And now we can see how much fabric did we save. If we go to the fabric section and see what is the present status of all the rolls, we'll be able to see that whatever fabric is left is less than the one piece consumption of our garment, and the complete savings that we have had is in the form of a complete roll. 16.6 meters here is not accumulative of all the end bits, but one complete roll. Also, if we go to the report section, we can see our savings there. If we go to fabric reconciliation report, we'll be able to see that 16.6 meters returned and saved, not in the form of n bits but one complete length of roll. This is 1.16% of the total fabric that we ordered. So what our software does is that it saves fabric not in smaller chunks but a complete length of roll that can be actually utilized. So if we go back and see again what we did, we'll be seeing that we got the fabric in-house. We saw that there is variations in the fabric rolls. According to different parameters, we grouped it. Then we made the new markers accordingly. We did a roll allocation using the complex algorithms such that the best utilization of the rolls could happen. And in the end, we effectively planned our remnants, and finally we had savings in the form of a complete roll. So that's all for the variations section in our software. For more details, you can contact us at sales@intelocut.com or you can call on these numbers. Thank you and goodbye.